Now, let's come to the transport layer. This is the fourth layer of OSI and it has various tasks, which is why it is called the heart of OSI. The very first job it carries out is to identify services based on the transport type. We can have many transport protocols in our discussion, but most of the time, we talk about TCP or UDP because these two protocols cover majority of the applications when it comes to transport. TCP stands for Transmission Control Protocol, which is considered as a reliable protocol as it has three-way handshake feature. For example, if a host or client device wants to communicate with a server using HTTP port 80, it has to send TCP synchronization request, called SYN, where the server responds with SYN ACK, and client confirms the receipt of the message with ACK or acknowledgement. This acknowledgement feature makes TCP reliable. Here, HTTP is using TCP as a transport protocol with protocol number 6. Some of the TCP-based applications are Telnet, FTP, SSH, and so on. There are many other TCP-based applications, which you can easily find on the internet with its port and protocol details. Another widely used transport layer protocol is UDP, which is considered as connectionless or unreliable transport protocol. This is designed to provide faster communication between client and the server. Some of the applications that use UDP as a transport layer are DNS, DHCP, and so on. We will cover some of the applications in the later topics. The protocol number for UDP is 17. Up to this point, we have discussed about protocol and port numbers, not to get confused with these two things, as port numbers are defined by application layer, which indicates a service number being used by an application, whereas the protocol number is used by transport layer to carry applications from one host to another. Once the services are identified based on their transport types, they are grouped together and multiplexed before passing them to the network layer. In this example, we have TCP-based applications HTTP and FTP and UDP-based applications DNS and DHCP. They all are grouped and multiplexed within protocol number 6 and 17 and sent to the network layer. Now, let's talk about fragmentation and reassembling. The transport layer is also responsible to split data into multiple fragments and give sequence numbers to each fragment. The sequence number is utilized by the receiver to reassemble data in the correct order. Now, we are moving ahead with windowing. Windowing is a flow control mechanism used in the transport layer, layer 4, of the OSI model to manage data transmission between sender and receiver efficiently. It ensures that the sender does not overwhelm the receiver by sending too much data at once. In some cases, the sender and receiver might have different resources capabilities. If the sender is strong and sending an amount of data, but the receiver is taking time to process it, it causes delay, and it's highly possible that the data can be missing. In that case, an acknowledgement is sent by the received for a number of packets it received, which is considered as a window size. In other words, the amount of data or number of packets the sender can send without requiring an acknowledgement is windowing. This is how congestion is prevented, as the remaining messages are stored in a buffer memory until the receiver is able to process further requests. Sometimes, the receiver might send windows size of 0 that tells sender to pause the transmission. Here we are about to conclude transport layer. The final task we are going to discuss is retransmission in the event of error detection. The error detection function is done by the data link layer, which we will cover shortly in the data link layer section, whereas the error correction is done by transport layer in case of any missing data sent by the sender or any error found on the received data. This is done by checking checksum value. Remember that, if that data is correct, the acknowledgement is sent to the sender, otherwise, the negative acknowledgement sent so that the retransmission could be initiated by the sender for the missing segment. Once received by the receiver, the data is reordered based on its sequence number and reassembled. As we can see, The transport layer changes the format of data as the source and destination port information are added to the data to create a segment, which is called an encapsulation process. Moving to the network layer, this layer defines two protocols, routing and routed protocols. The routed protocol is used to identify a host, or we can give an identity, like an IP address. There are other routed protocols as well, but they are vendor-specific and no longer used in modern networking. For that reason, Internet Protocol, IP, is widely used with its current version number 4. We will cover IPv4 and IPv6 topics later in this course. Talking about routing protocols, as the name suggests, the routing protocol shows the route or path to reach a specific destination. We will discuss a number of routing protocols later in this course. As discussed earlier in this section, the transport layer creates segment including source and destination port information, which is further encapsulated within packet in the network layer. The packet is created adding source and destination IP address followed by a time to leave value, which is 8-bit values that gives maximum value of 255. Here, TTL value 255 refers that the packet can cross up to 255 hops or routers. We will discuss more on this in the IP routing topic, and we will also see how it works as we move through the labs. In this section, we will discuss about layer 2 or data link layer, which has two sub-layers. However, the LLC layer, which defines WAN protocols like HDLC, PPP and frame relay, is no longer covered in this course as they are not used in the modern networking. So, let's talk about MAC sublayer. MAC stands for Media Access Control, that defines 48-bit addressing system, and it is written in the hexadecimal format. The hexadecimal numbering system has total 16 values starting from 0 through 15. The 10th value is denoted as A, 11th B, and it goes up to F. In MAC address, the first 24 bits are called OUI, that stands for Organizationally Unique Identifier. As the name suggests, the OUI bits are given by IEEE to the manufacturing vendor so that the MAC address assigned to a networking device would be unique. Remaining 24 bits are defined by the vendor itself, which is called vendor code. In the switching topics, we will see how MAC addresses are used during data transmission, as the technologies that are relevant to data link layer will be covered later in this course. As you can see here, the format of frame includes destination and source MAC followed by packet and FCS. The frame check sequence carries CRC value, called cyclic redundancy check, that is used to detect error during transmission. Let's recall that we discussed about error detection and correction in the transport layer. The detection process is done by reading FCS value, which should be identical between source and destination. Any changes in the data would result difference in FCS value as well, which suggests receiving end to discard the frames. Up to this point we have covered from application to the data link layer. In the next video we will cover physical layer and related technologies, including physical transmission mediums that we use in real-time environment. Please leave a comment down below to ask any questions. I will try to answer them as quickly as possible. Thank you for watching and see you in the next video.